Alright, this is going to be a lengthy video because I've got quite a few things I wanted to talk about, from Strat pickup height adjustment to polarity of the magnets to the output of the pickups. And it dawned on me last night that I said, shoot, I bet you I could just get a better indication on the output of pickups by measuring the voltage that they generate, because magnetic pickup is nothing more than a voltage generator. It is in millivolts, so it's very small amounts of voltage, but that's what drives the amp. But you can see right now my meter's reading 0. I've got the same hookup I had reading the ohms, the resistance of the pickups. And let's see, I've got my black Strat right here with the vintage pickups in the neck and bridge, and then the hotter new Rumpelstiltskin pickup in the neck. And it's turned out to be a really cool combination. But I'm going to break this video into sections, because the first section is going to be showing you how to somewhat test your pickups for output. Turns out there's a whole bunch of discussion on the internet. This has been going on for years and years, since, I don't know, the earliest I saw was 2008, 2009, discussing how voltage isn't a good indicator of output on your pickups. But it turns out Dimarzio pickups give you the output in millivolts on all their pickups so that you can compare. So they are one of the few companies, I think, that use that. It would have to be standardized if it was going to be relevant across every manufacturer's pickups, which they don't have a standard procedure, and I'll show you why that's so difficult. But I thought it was a good idea until I started doing Google searches and finding out how much variation there is. But it's interesting. I mean, it's good to know. You might be able to get some kind of usage out of it. But I found it was a hard thing to do with a fluke or any kind of meter. I'm plugged in. I've got everything all the way up. I've got on the neck position, and I'm going to play it. You can see when I just move my hand that I generate a few little millivolts just by touching the string. There's 10, but you notice that it fluctuates and jumps all over the place. And the other sections are going to be checking the polarity. One of my subscribers, Conjuring, pointed out the fact that I might have two pickups, since I'm using old and new pickups, that would be out of polarity phase of the magnets. They have a north and south pole, and up till 1959, I think, Fender used the north polarity, and then they switched to south. Hopefully I've got that correct. Let me look it up. But anyway, I'm going to go over the polarity, how to check it with a compass. I tried checking it with a magnet, and that's not a good idea. I'm also going to talk about storage of pickups, which I never thought of, as far as maybe damaging them if you just throw them in a box altogether. And also I'm going to talk about height adjustment, which I just made a discovery. Strats have this thing called Stratitis or something like that, where the magnet affects the intonation, the magnetic pull, and it can affect the sustain. I'll show you what I discovered on that. And what else? There was something else, but I'll break it down into sections in the description so you can see. This is already getting long, but the tricky part with measuring the output in millivolts, which I have a millivolt setting on this, is how hard do you strum the guitar. The harder you strum, the higher the voltage is. So for Dimarzio to say they have a standard, they have some kind of a machine or something. Somebody said they just pluck the A string with a machine that plucks the same thing all the time so they can get a consistent input of the pickups as they test them. See, I'm doing the A string right there. But you see how much it fluctuates. Look, I was just going to strum all the strings. And you can see it's jumping all over the place. So how am I going to be able to figure it out? Well, this is something with the fluke that I figured does help. You put it on min and max setting, which a lot of meters have. And then you do it. When you hear it beep, that means it's got to... Now I'm going to have to try to stay consistent between all the pickups. And I stop, and then I push the hold button. And you can see max is 131 millivolts. Minimum was 0. And then they give you an average, and I'm not sure how they calculate that. Average doesn't make a lot of sense to me. But the max was 131.1 millivolts. All right. So I'm going to try to strum exactly the same. Reset it here. Put it back on. Try to strum exactly the same on the middle pickup. Now, it jumped up a little bit there at the end. Now, my middle pickup's the hotter pickup. I'm surprised there wasn't more difference there. But I got a 137 millivolts, so it's a little bit more output. And the ohms on that is 6.1 kilo ohms. I'm sorry. And okay, so now we're going to do this again on the bridge pickup, which is about 6.2 or 3 in circuit. Well, you see it's jumping around. I forgot to put it on min max. Here we go. And you see that the output on that one, even though it's a higher ohm, is less output. Now that could have something to do with the magnets or the wire. You have to know what gauge wire is on these things, and I'm not even sure. On the vintage ones I can look it up. On the Rumpelstiltskin I'm not sure. So yeah, they're pretty equal though, and that's one thing that I was thinking, well, you might be able to use this to balance your pickups. In general, you don't ever want your neck pickup to be louder than your bridge pickup. And so you might be able to flip things around. I mean, usually the hotter pickup is the bridge, and then the neck is usually the weaker, or maybe the neck and middle are about the same, but all the sets are different. So what I'm going to do now, since you saw how I at least was able to keep the fluctuations to a minimum with that min-max setting, I'm going to use the, going to test the green Texas Specials here, which I have not done. This will be the first time, so you get to see it with me. And I'll do the ohms first because I'm kind of curious myself. So for the neck is about 5.95 kilo ohms. The middle is 6.32 kilo ohms. And whoa, the bridge is 6.8. It's getting pretty hot as far as I can see. And in-betweens are in parallel, so they cut the resistance in half. Alright, well, let's see how much output these things put out. I'm in the neck position. I'm going to put it on min-max. Wow, that thing really was jumped up there. That's 160 millivolts. So that's pretty hot, you know. And I mean, these things are hot. Now let's go to the. We'll go to the middle pickup, which should be even hotter. And it's not. So that's another thing that has an effect, is the distance away from the bridge. The neck pickup, the reason you don't want it as hot is because the strings vibrate more there and they put out more vibrations. You know, it just vibrates more at the neck than it does at the bridge. So I got 132 versus 160 on the neck. Now I'm going to go to the neck here. I mean the bridge. Now that's pretty interesting. So the neck is really pretty loud, even though it's lower ohms than the other pickups. I mean, it's the bridge is only 103 millivolts. Now let's go back to the neck again. Check the check the ohms again. Here the ohms, 6.8 we had. And the middle is 6.33. Whoops, what am I moving that for? And then the neck is only 5.95, but when we go to check the output of the neck, I didn't get 160 this time. It's a little more reasonable, but it's still higher than the other pickups. So that just goes to show you how difficult it is to judge a pickup by the resistance and the output. But in general, I don't know. To me, right now, that would make me, I don't know. That's the weakest pickup. So that's the way these sets are set up at Fender. Now, the one other thing I was going to talk to you about is mixing and matching different brands of pickups, which I've never done before, and that will be another section too. And okay, this is the first section. That's pretty much done. Okay, here's section 2. This is something I never really thought about, because you buy a set of pickups, you put the set on, and you're done with it. And I mean, they make guitars all the time with a mixture of pickups, a mixture of single coil humbuckers, rail type, all kinds of different pickups on certain guitars. But on a Strat, you want it to look nice, so you keep it consistent. That's the way I've always felt about it. But it turns out just the happy accident that I had having to take out that weak pickup, or wanting to take it out, turned into a pretty cool little combination of pickups. I've got this one is the 1964 with Formar wire. That's the same. And I took out the original neck and moved the middle here, and that left me a hole here to put a pickup. So I took my set of Rumpelstiltskin Gypsies, which actually I just noticed yesterday. These also have the reverse stagger, so they're like a stagger for a left-handed guitar. So now I've got standard stagger here, vintage stagger, and then a left-handed stagger here, which I don't know if that's going to make much difference, but I'm just saying the combinations are endless. And sometimes it works, sometimes it doesn't. But I was going to put in the middle pickup of the Gypsy set, and then I thought, well, the bridge on the Gypsy is the hottest one as far as resistance goes. The kilo ohms was 6.2 or 3, so, and that was going to match this one closer. So I actually took the bridge pickup out of the other set and stuck it in the middle here. So as far as having, the outputs, the way the sets are set up when they send them to you, have to have it that way, or getting them switched. I know one of the subscribers got his noiseless pickup switched, and he wanted to know how to figure out which one was which. And it may not make that much difference, or it might be fun to experiment. Like I said, you generally don't want to get this one too hot, or it'll sound out of balance. This one will be real loud because there's so much vibration here. You can see that there's a lot more vibration here than there is here or here. That's why the different positions sound different. But either way, the combination worked out great, and this one is still hotter than these two pickups, probably because this is enamel wire. It's new magnets. I think it's Alnico 5, and I'm pretty sure these are too. But these are probably a little weaker, not much. Some people think they get real weak. Bill Lawrence says they lose, I don't know, 0.5% over 100 years or something, so they don't really go too weak. But I've had these remagnetized, and I don't think it made a whole bunch of difference. But this one's like putting a little boost pedal on your guitar. When I hit that middle pickup, I really love playing this thing because it's hot and it's bright, and I think the mixture between the vintage and the bright new one actually gives the in-between positions a cool, brighter sound to them. So I'm just saying it might be good to experiment. Now I know some people say, you shouldn't experiment, just put something in there and play. But I'm telling you, all the experimentation that I've done, somewhere along the line I learned something, and somewhere I get a happy accident and things just sound better. I mean, it's the same with all my amps. Tubes, different tubes, different alterations to the circuit. Now I don't do out and out mods to my vintage amps, but I do try to make them consistent. If Fender made changes over the years, I'll try to experiment with Fender's changes. Either way, that's this section. That there's no rules when it comes to having 2 or 3 sets of pickups. You can switch and mix and match them any way you want and just see what happens. And that can be a pain, taking this thing apart all the time and rewiring. So you might want to check the outputs, try to put the hottest one here, the weakest one here, and one that's semi-balanced in the middle, and start there. Okay, that's this section. Alright, this section we're going to talk about magnet polarity, which I never thought of. Thank you, Conjuring, for reminding me. He said, well, you said you might have these polarities wrong because this is a vintage pickup, this is a new pickup. Some are North Pole polarity, some are South Pole polarity. Fender, for some reason, in 1960, I'm looking at this chart, went from a North Pole polarity to a South Pole pickup. So let's say these are before 1960, which they're not. These would be North, and let's say this one's a standard, the new pickup's a standard South. You run those together, and you could have phase problems where it just cancels out and sounds really bad. Luckily, I don't think anybody would have to worry about that unless you've got a lot of older pickups. I think all of them are probably South now, but don't quote me. I haven't looked at very many specs on pickups. But this is something you don't want to do. I didn't have a compass So I had a little magnet. I tried to find a magnet and see, well, okay, if it repels from this magnet, it should repel from every magnet. Well, I had a round magnet. It turns out you had to hold the darn thing a certain way to get it. So I'm sitting here trying to get it to stick or repel and turning this little disc, and it was a pain in the butt. And then after I started reading about magnets and storing magnets or storing pickups, said whatever you do, don't put another magnet close to it. You can't damage these things unless you really put a strong magnet to remagnetize it or something, and you reverse the pole. You can do that, I think, reverse the pole with a magnet with a machine. But I didn't hopefully do anything to it. Either way, that gets me to the storage topic. You don't just throw your spare pickups in a box, which I was doing. You can actually weaken the magnets over time, or I guess damage them. I don't know what it would do, but Bill Lawrence, he's a pickup expert, he said don't store them like that. Now what I did was I went back and separated these as far as I could in the box and kind of locked them in there so they won't move. So that should be fine to store them like that. But just don't throw them in a box, just jumbled up. Now if they're in a set and they're in the set configuration, that's okay too, I think. I've got this set here, which these are the Lawlers. I don't know if you can see. They're kind of just stored like they would be in the guitar, so that's fine, storing them like that. So that's a storage thing that you want to be sure that you're careful. You don't want to get magnets close to them. But I did go buy a compass, and it's kind of fun to watch. Look here. Here's my new compass. Now, you see the needle is pointing, let's see, the red part is pointing to the north. That's where. Now watch when I get just even close to these magnets. Watch that needle. See it? Look. It's going earth, magnetic north, to now the magnetic north of the pickups. And luckily, they're all they were the same. Now, if this thing was, yeah, it's kind of a cheap compass. I gotta keep it level. Now, if one of these was north versus south, these are south because the north opposites attract, so the north is going to the south. Now, if one of these was north, then this needle would completely flip around immediately. It'd go bleep, like that. So, that's why you check the polarity. Alright, that's this section. Okay, now we're going to go microscopic on you. This is my pickguard. This is what you call a green guard, vintage green guard. And they notoriously shrink. It's because of the material they're made out of, which Fender stopped doing it, I think, in '64. I forgot the different materials, but the green guard is known for shrinking, which is a real pain in the butt. You can see the kind of the gap there on this neck pickup, because I've actually had to take some material out of the cutout to keep the pickguard from tilting the pickups. It's hard to see, but when I first got this, it was so shrunken that the pickups were totally all tilted inward, and it really did skew the way the magnets were aimed at the strings. And you can also see the big gap right here between the neck. That's how much this thing has shrunk. You know, normally the pickguard is right up against the neck. And in general, you'll see like on, I think it's Evan, I forgot his darn name now. You'll notice that some people have the tip of this little sharp tip broken off. The pickguard will just be broken because it shrinks so much that it just breaks this tip off. I was lucky enough to, these were really angled in. The screws were going at a 45-degree angle almost. And I had to take the screw out and pretty much drill a new hole in the body and straighten it out. Otherwise, this would have eventually broken. So I had to go in there and fix all this. When it shrinks up so tight around the pots that I couldn't even get the pots out. I mean, they were super wedged in there for 40 years of shrinkage. Once I got that out and relieved that pressure, it was just so much better. But what I was going to show you is on pickup height. The good thing about this little mess here is it gave me a way, after I changed these pickups, it gave me a way to quickly adjust the height of the neck pickup, which is what can cause your stratosis or stratitis or whatever it's called, where you get your magnets too close to your string and it causes a weird kind of a oscillation and causes the string not to vibrate like it should because the magnet's pulling too hard on it. And Stevie, if you go to his settings, he had his neck pickup pretty darn close. But yesterday when I was playing with this thing, this screw kept popping up and this pickup kept popping up, and it would just, I wanted it down low to get it away, and every time I would stop it would eventually just pop back up. And I said, darn, I'm going to have to take this thing apart again. And I said, I gotta fix that. I'm tired of it. So I thought I probably needed to put in a stronger rubber grommet which pushes the pickup down. So I was able to take this off without taking it completely apart again and shove an extra little one of those rubber grommets in this adjustment screw to push down harder. And now it's really solid. So when I screw it down, it stays down. But during the process when I was pushing up and down, you can see there's still some movement. I had a lot of movement. I probably had about maybe 1/8 of an inch of movement. So I was pretty much able to adjust the height of the pickup instantly. I could pluck the string and push the pickup down and pluck it. So I was going back and forth, too close to farther away. And I could hear the oscillations start when I would let off and it would go up closer to the string. I said, shoot, I gotta fix this thing so I can get that oscillation to stop and get a clear bass note sound. So I was able to fix it, and it really does make a difference in the way it sounds. So there's a fine line between getting those things too close and too far away. And you know, they measure it by pushing down on this fret, the last fret, and then measuring. And I don't know what that measurement is. I'll put it in the description just so that you know, but it has to be pretty far away. Not as close as Stevie had it, I don't think. And to get a really clean sound, and he may not have had it that close. That was just this one book that had his adjustments in there, Dan Earlywine. But that's the last section, I think. Hopefully this is a good conversation. I think it's interesting, and I'm pretty sure you'll get some benefit out of that, especially this pickup height adjustment. The other pickups have the same effect, but not as pronounced as the neck pickup, and on the bass strings mostly. But if you have a hard time intonating your guitar, and it just, especially when you start fretting up at the 12th fret, it might be because you've got them too close. You try adjusting your pickups down a little bit until it sounds better and easy and intonates easier. Alright, I'll talk to you guys later. Bye.